Okay, so this part we're going to be going through writing formulas for ionic compounds. So I find writing ionic compounds, apologize for that noise, we have some construction happening. So I find writing the actual compounds quite easier than actually naming them, I find. In this particular one, all you need to have a look at, so if at any time the actual cation itself has a Roman numeral, then it shows you the charge of it. It tells you the charge, whereas everything else, you just need to use the periodic table if you don't actually know its actual charge to see to actually write the actual formula in proportion, because remember, you need to balance the charges. The charges have to come up with a neutral charge. So in this particular instance here, we have chromium, which is 3. So we know that chromium is 3+. And if you really want to do this the slightly longer way, first get its actual symbol, and you can do a little charge here. So chromium 3+. You know that it's chromium 3 because of that Roman numeral here. Now phosphide, so phosphorus is by themselves. We know that phosphorus by themselves is going to be 3, and it's phosphide, not phosphate. If it's phosphate, then it would be PO4. PO4, 3 negative as well, but phosphide, it's phosphorus by itself. So in this particular instance, they actually neutralize each other to make a neutral compound, so we don't actually need to multiply either of them. So that actually, the compound will just be CRP, because chromium phosphide, that is its actual ionic compound name. Let's move on. Silver sulfate. Now silver, we can very make sure, and there's always going to be some sort of valency table around. Either you can access one, or in an exam you're most probably going to be given one. But silver we can always remember, and it's never going to change. It's going to be silver plus. And sulfate, so remember anything 8 on the end of it. 8 suggests that it's going to have sulfur in it, and it's going to have the presence of a whole heap of oxygens. Usually 4, but sometimes 3, like in nitrates. But sulfates and phosphates, there are 4 oxygens. So here we have sulfur, and it's a sulfate, so it's going to have 4 oxygens. Now sulfates have a charge of -2. So in order to actually neutralize that charge, we're going to need 2 of these guys, because to neutralize it, we have a -2 charge. We only have one, silver only has 1 positive, so it has to end up being Ag, do the arrow, Ag2SO4. Here we don't need the brackets because the sulfate ion itself isn't being multiplied. Let's have a look here. Ammonium acetate. It's one of those really tricky ones because there's going to be lots of letters. There's a couple of ways to actually write it. So ammonium is not ambiguous. Ammonium is always going to be NH4, and it's going to be a +1. Okay, ammonium ion is positive. Now acetate ion can be written a couple of different ways. It can be written CH3COO negative, okay, or it can actually be written C2H3O2 negative. Now you need to make sure that you know that they can be written in both ways and not be tricked. And also with the actual name itself, we can also call it ethanoate. So it's one of those tricky naming ones. So you can write either way, but you can remember it can be acetate or ethanoate. They're both the same thing. So here, +1, -1, they're just going to balance each other out. They're going to neutralize each other, so it's going to be NH4 CH3COO, or NH4 C2H3O2. Okay, and that's balanced. Now it looks kind of confusing, but you know that ammonium, you don't need brackets here because neither of them are being multiplied. So let's have a look at this one. Now here is something a little bit tricky, sulfite. Now when sulfite, when you get a suffix of ite, as opposed to 8. It just means it's just one less oxygen than the 8 form, and it's going to be the same charge. That one you can remember as a rule when you see an ite, specifically sulfite. So sulfate, we know is SO4, so sulfite, and I'm going to need a bit of room here, sulfite must be SO3, 2 negative. And we have iron 3, excuse me, so iron must be 3 plus. And here, when you have 3's and 2's, charges of 3's, positive 3's, and charges of negative 2, or vice versa, charge of negative 2, of positive 2, and negative 3, the best way is just to multiply those charges by each other. So if you multiply iron by 2, iron by 2, and you multiply the sulfite by 3, you're going to balance out the charge, because positive 3 times 2 is positive 6, and 3 times negative 2 is negative 6, so that becomes a neutral compound. So it's going to be Fe2SO3, and this time we're going to need brackets because we're multiplying that entire iron by 3. Okay, so we have iron 3 sulfite here, Fe2SO3 3. Great. And this very last one, copper 1 fluoride, it's quite easy because copper, if it's going to be copper 1 plus, and fluoride we always know as negative, they are going to neutralize each other, so it's going to be CuF. But here, notice here, especially when you're naming things, make sure that you spell it fluoride, and sometimes, because you'll get caught out when some people say fluoride, which is not quite correct. So make sure you write it fluoride, not fluoride. So that incorrect. Hopefully that was helpful. And if anyone needs any practice, I've got lots of sources to practice. So just email me. For those who don't have my email, write a comment here on YouTube, and I will most definitely reply to you. And I'll give you some practice problems and I'll even help you out. So hopefully that was helpful, and we'll see you in our next video.